Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. Cloud-based Jenkins X has a new UI made for the demands of continuous development. Learn more about Cloud-based Jenkins X and the Cloud-based leadership in CI/CD at cloudbees.com. Hey, we're here today at the IFX event in downtown Las Vegas, being held at the same time as the Reinvent conference. It's being hosted by Packet, and Packet is a sponsor of the New Stack. It's really a place where you're going to find people talking about as much development as next generation infrastructure, really. And my guest here, I think, can talk about infrastructure pretty well, considering his background and what he does for a living. I'm joined by Luke Hoban, CTO of Pulumi. Hey, Luke.
Hey, how's it going?
Great. And Luke, I wanted to talk with you a little bit about your experiences with cloud services, and then we can talk, I think, specifically about Pulumi and this concept of modern infrastructure as code. I was looking at, I was looking at your background, and I saw that you worked both at AWS and Microsoft. I'm curious about, what did you learn about managing services or developing services for infrastructure at each of these two companies? What were some of the similarities? What were some of the differences?
Sure, yeah. So, I spent a long time actually at Microsoft. Most of that was really building kind of developer tools. So not even in the cloud infrastructure space. That was sort of building tools for developers to kind of scale up the complexity of the software that they built. And over time, Microsoft, when I joined, was focused on the desktop. It was focused on the early .NET for the web, these kind of scenarios. That over the last 13 years transformed from desktop and the web into now the cloud being the dominant platform. And so in the last 5 years or so I was there, a lot of what we were doing was focused on bringing developers into kind of the cloud platform and enabling them to be successful there. Then after Microsoft, I went to AWS and worked on EC2, and so built sort of core cloud infrastructure. And so kind of get a front row seat working inside the EC2 team on sort of what's going on, both from a sort of raw infrastructure perspective, like what are the different infrastructure products that are coming out, and I got a chance to work on launching new GPU accelerated instances and FPGA instances, and some of the burstable instances with the T2 and those sorts of things. And so we saw like a lot of the infrastructure changes that were happening. But I think one of the things with Pulumi that we've really done is sort of bring those two worlds that I had a chance to work in closer together, the sort of application development side and the infrastructure side. How do we bring those together, and how do we enable sort of developers and infrastructure teams to take advantage of all these infrastructure building blocks that are being built now by AWS, by Packet, by all the other cloud providers out there.
Right. And so in your experiences in building developer tools at Microsoft, how did that influence you in your work at AWS when you were building out, more infrastructure-related architectures?
Yeah, so I think building for developers, it gives you a sense of sort of that the sort of aesthetic that a developer has around a really great experience for kind of working with the APIs they're working with the development tools they're working with, and so really understanding that sort of aesthetic that a developer is going to fall in love with and really enjoy using. And that's something that honestly AWS did a great job of when it first came out, the API-driven access to infrastructure. That was a thing which wasn't nearly as sort of well understood of a pattern, that you could put all this power of these infrastructure services behind rich APIs, allow developers to program those and build complex applications on top of them. And so I think bringing that mindset of that sort of developer-centric mentality really is something that can benefit us in a lot of different ways in the cloud space. And I think that was true at AWS. It's true of many other cloud providers, and I think it's something that at Pulumi we're trying to take even further.
So at this event here, IFX, they talk about the history of hardware architectures and how it correlates to software development.
Yeah.
They cite, for example, Apple in its early days in developing hardware architectures.
Yep.
So so the software could do what they wanted it to do. For today's infrastructure, how is that still being borne true?
Yes, I mean, I think it's being borne true, as much or maybe even more so in terms of how rapid the change is now with the cloud, because we can sort of get democratized access to these new kinds of compute much more quickly than we could have before, when we had to go and, and as an individual, I'd had to have the money to buy some new complex piece of hardware to build some systems around it. I'd have to have that capital. Now, AWS has to have enough customers across their entire customer base to justify it, and then they can build custom FPGA instances. They can build custom machine learning inference chips that they announced yesterday. They can build all of these really customized and powerful forms of compute hardware that now anyone can get access to just by having an AWS account and being willing to spend a few dollars an hour to access these things. And so I think that's sort of democratized access to some new sort of computer architectural concepts. But I think the other side, which is closer to kind of what we end up working with developers on more at the Pulumi layer, is really how developers think about deploying their code into these compute platforms. And increasingly that's moving from the sort of traditional VM-based world, which itself revolutionized the way people thought about this back 10 years ago or so, now into containers, obviously. Kubernetes is a control plane over top of that, and serverless, and even sort of the evolution of sort of these container and serverless platforms with some of the technologies that have been announced over the last few years, like AWS's Fargate and the support they launched for Kubernetes plus Fargate yesterday. So I think these technologies are allowing people to really think differently about how they actually deploy their applications, how quickly they can deploy applications, how they can manage that in these environments.
So speed, delivery. One of the questions we hear technologists talking about, they ask, what about resilience? And what about the actual brittleness still of software in itself, where you'll hear technologists say it still feels a bit like it's being taped together, not even with duct tape, but with Scotch tape, I think someone said yesterday.
Yep.
And that does relate a lot to the infrastructure and how the code gets deployed on the infrastructure. Sure. So how do you view in that context infrastructure as code? Because I know that's a concept you talk a lot about. Yeah.
Well, I think one of the aspects of that is, one of the things, AWS's approach to building out the portfolio of services they've built out over the last 10 plus years has really been focused on these building block services. So individual services which do one job, they abstract away some of that operational complexity for that individual service, and you pay for AWS to manage that for you. And so those services themselves are not brittle. What becomes brittle is that to build real applications out of this, you've got to combine all these services. You've got to do all the glue logic that sits in between these things. You've got to sort of operationalize the way you deploy into all those building blocks. And so that's where infrastructure as code tends to come in, is, how do we bring some more robust engineering practices around the way that we describe how we're going to build up all these real applications on top of these rich building blocks that AWS and Azure and GCP have available, and how do we build the complicated kinds of software and increasingly complicated kinds of software we're trying to on top of these things. And today that really is the pattern that's evolved has been this infrastructure as code idea. This is the robust way that you can describe the infrastructure that you want to have in your cloud platform, is to write it down as code. And I think that's a pattern that's seen a lot of success over the last several years, but really it's still just at its earliest days. It's still done in a way which is not nearly as sort of, you think about the software engineering practices people apply to their 100,000 line application code bases, and the robust IDE support they get, the type checking they get, the componentization they do to make sure that they're not copy pasting stuff around. All of these things are things which we should be thinking about in that infrastructure side as well, to make sure that we're not just duct taping things together. And we're not really there yet, and that's something that Pulumi is kind of really working on, helping to bring to light.
One of the critiques that came up during KubeCon focused on how it's not really clear who does the configurations anymore.
Yeah.
And developers are increasingly using YAML almost as script, right? As IT professionals have done for decades. Mm-hmm. What are the ramifications of that?
Well, I think there's two pieces to that question that I think are really interesting. One is the who is doing it, and I think that is something that's shifting a lot. 5 years ago, you would have had your dedicated infrastructure team that's sort of managing the infrastructure, and that team would have been responsible for some fairly slow-moving infrastructure. They'd have some EC2 instances, some networking. It might change once every few months. It wasn't this sort of fast-moving piece of infrastructure. Today, you've got infrastructure that's moving at closer to the same speed the applications are changing, right? So as the application changes and wants to expose some new capability or use a new queuing service or whatever, we're actually having to make changes into our managed infrastructure. And that's leading to these things needing to be owned more by those development teams. And so we're seeing this combination of responsibility both shifting and sort of being a shared responsibility between shared infrastructure platform teams and development teams. And in part, that's bringing to light some of these challenges around the way that we do this stuff. The idea that we just write piles of YAML and just copy paste it around between all our different code bases is starting to feel, you go and present that to an application developer and tell them that's how they're going to define their infrastructure. And they kind of look at you like, hey, I thought this stuff was important. Why, if this is so important, why aren't we testing it? Why aren't we, componentizing it? Why aren't we, having IDE support to help us to be productive in developing it? All these things they're used to having in their existing programming languages they're working with, they're lose as soon as they move into the infrastructure space. And so I think it's putting pressure on the space to modernize and become a really robust software engineering discipline. And I think that's part of what we're working on.
And so you wrote a post in October, and you talked about this concept of modern infrastructure as code. And I'd like to review parts of the post at least. One of the things you say in the post is that we're facing this time where there's more languages, there's features that bring deployment. What you're saying, what we really need is the ability to be inclusive of more languages, features that bring deployments closer to the inner development loop, like watch mode, more libraries of off-the-shelf patterns and practices, and the ability to test your infrastructure more easily.
Yep.
What are you meaning by that? What are you trying to get at here with that kind of a statement?
Well, I think
it's just good common practices that are just fundamental.
Yeah, I think some of these are just good software engineering practices, right? If I'm an application developer, these are things which I just making sure the inner loop of my development is as quick as possible so that I can test out ideas, I can experiment with things, I can learn quickly, I can iterate towards a great result. That's something that we've known for decades is super valuable to application development teams being able to move fast and build great software. And so how do we bring that into the infrastructure space? How do we enable people to iterate really quickly on infrastructure and build that? Similarly with testing, we would never build a piece of software today in an enterprise without writing tests for it. That would never be an acceptable thing. That's just part of what we think of as software engineering. That's not the same sort of standard that we're applying today to our infrastructure. In part, that's because it's been harder to do. But we can bring some of the right tools in place. We can bring some of the practices from that software engineering side of things in. We can apply those in, and we can actually kind of really think about testing as a core part of how we build out our cloud infrastructure as well.
So what are those spectrum of testing scenarios that now Pulumi 2.0 includes?
Yeah, so I just to step back a little bit on the Pulumi 2.0. So Pulumi 1.0 we launched back 3 or 4 months ago. That was sort of the culmination of the original. We launched Pulumi about a year and a half ago. And Pulumi 1.0 was really taking that initial sort of set of stuff we'd done and saying, hey, we've gotten to that point now where it's being used in production by a bunch of folks. It's a robust platform that we can build on top of. We're going to maintain stability for that. Make sure that if folks are building on top of that, they have a stable foundation. Pulumi 2.0, we just announced earlier this week, actually, that's something that's in progress right now, and we're going to be launching in the early part of 2020. And that's got a few sort of key things to it that we're focusing on. Testing is definitely one of them, but a couple of the other ones are really expanding the portfolio of languages we support. So one of the key things that Pulumi does is bring, instead of using YAML or JSON or some of these sort of text-based formats like that, we're using existing programming languages, so giving you the full flexibility of JavaScript, Python, Go, and other languages. And part of that is we're expanding. We just launched a preview of .NET support, and we have a preview of our Go support as well, and those are going to be part of that 2.0 release.
So the 2.0 will come when?
Early next year, early 2020. Yeah.
Early 2020, and that's where you get into being able to support more languages.
Right.
What languages did you add? are you?
Yeah, so
adding?
we just launched a preview of our .NET support a couple weeks ago. Yeah,
Okay.
and that's we've seen a ton of folks jumping in and using that. There's a very large .NET developer base out there, obviously. One that I had a chance to spend a lot of time working with while I was at Microsoft. And so we're really excited to bring that. And then we've had Go support in preview for a little while. We're working on that, bringing that into GA as well as part of this 2.0 release next year. Another big piece that we actually launched, sort of in the same ballpark as the testing, which I could talk about, is we launched a preview also of kind of a new policy as code framework. And so one of the things we've seen a lot as folks have been picking up, to describe the infrastructure, is the real desire to be able to enforce policy around that infrastructure. It's really important for compliance, security reasons to be able to enforce that certain things are going to be true about my cloud infrastructure I deploy organization-wide, not just because I did a good job of doing it for this one stack, but that these are policies that must be met by all infrastructure that gets deployed. And so we kind of have taken the same lens of, hey, let's bring real software engineering practices into that space as well. And so as part of that, we've included sort of the ability to use real programming languages, JavaScript and TypeScript, to describe that policy and describe how to verify that your infrastructure is obeying the sort of compliance criteria you've set.
So in 2.0, though, you will be offering more spectrum of testing scenarios,
Yes.
like you're talking about. And that includes unit testing.
Yeah.
That's gaining a lot of visibility these days. Why is that? Why do you think unit testing is becoming so talked about?
Yeah, so I think it's really interesting. I mean, unit testing generally, I think, is so valuable as a general software engineering thing because it just moves. So that sort of shifting left thing. It moves all of that confidence and validation super early. You can run those tests really quickly. They can live right next to the code that's churning. They give you a really easy way to lock in correctness of a piece of code right next to that code. They're not sort of separated by space and by time in a big way from the code. And so unit testing, I think, has really become sort of the dominant form of testing by volume across most application development scenarios. And in infrastructure, though, it's really interesting because like infrastructure has not traditionally had nearly as much of a testing practice around it. And so some of the ways we think about these things are a bit different when we think about the cloud infrastructure space. And part of that for unit testing is actually there's sort of two pieces to unit testing. One is sort of unit testing that our descriptions of our infrastructure mean what we think they mean, in the sense that the programs that describe our infrastructure are constructing infrastructure which is what we intended it to be, and that's sort of the traditional unit testing. What we find is even more useful is unit tests that take an individual component of infrastructure and actually deploy it to a real cloud provider and then do some validation that it behaves correctly. So if it's going to spin up a serverless function, spin that up and verify that the serverless function does what you want it to do, and then tear it down. And so run these very short tests, but tests that really do actually run on the cloud, but validate still close to that individual component, and then still test each of the components you're going to build in isolation. Have those short tests that again live very close to the code in time and space, and then build up confidence by having that kind of testing and not have to rely as much on heavyweight integration and manual testing of your entire stack.
You have also have added Crossguard.
Yeah.
You are adding Crossguard. What is that? What is Crossguard?
Yeah, so Crossguard is actually the product name for the feature I was just alluding to a second ago, which was this idea of being able to enforce sort of policy as code. So to be able to take your all of the different deployments of infrastructure you're going to do across your organization and say, here's some security policies, here's some compliance policies, here's some cost control policies that I want to apply to my organization, and say I don't want any S3 buckets to be public. It is illegal for you to try to deploy an S3 bucket that's public. I do not want you to ever increase the cost of this stack by more than 10% in a single deployment. If you do that by accidentally deploying some large EC2 instance or something, we're going to flag that and fail the deployment ahead of time. And so we've integrated that into the Pulumi Infrastructure's code offering, this notion of Crossguard. But it's really a way to protect your deployments based on some organizational policy that you've developed.
So it allows you to validate that infrastructure, and that becomes security best practice too, doesn't it? And there's other security capabilities that you're going to be offering in 2.0. Maybe you could talk a bit about those.
Yeah, the biggest thing is sort of a bunch of
The
extensions
policy.
around this Crossguard policy as code. So, today we have the capability to kind of define those policies. One of the things we're going to be extending that with is some built-in policies for best practices around security on AWS, on Azure, on GCP, identifying places where you're doing things that are not the best practice way, and either warning you about that, or potentially even allowing operators to turn on a mode where that will fail deployments if they try to do that. And one of the key things that Pulumi can do that's sort of a bit unique here is because Pulumi is actually deploying your infrastructure. We can actually identify when you're about to introduce one of these problems and fail your deployment before you actually try to do it. A lot of the existing tools, even the tools built by AWS, for example, they have a lot of great tools for sort of compliance. But most of those things run after the fact. They identify if you've already introduced a problem into your production environment, and they help you remediate that. The key thing that sort of Pulumi can help with is not even introducing those problems in the first place. In fact, identifying them even on the developer's desktop while they're typing the code, right? They're adding some code to add some new capability into their infrastructure. They get the feedback, they get a squiggle in their IDE that says, this is going to fail because, it's not the best practice way to do this in AWS, right?
So this goes back to that concept of shifting left, really, and providing unit testing and being there with the developer while they're building out their code so it can meet the policy requirements and just live up to code that works. And
yeah, it's a consistent theme, I think, for what we do at Pulumi is trying to move a lot of those capabilities, closer to the inner loop of development. We've seen that, in our past lives working on developer tools and platforms for application developers. We've sort of seen that be a consistent recipe for empowering developers to move a lot faster and build software a lot more effectively, to give them the tools to identify those problems sooner, to iterate faster. And we think there's still a lot more opportunity there in the cloud infrastructure space.
So what are you hearing from developers here at Reinvent, and how does that affect your perceptions and thoughts about moving into the next 6 to 12 months? I get the impression that, as you just stated, Pulumi is focusing a lot on this concept around providing those policies, providing that unit testing, providing those built-in features that can just help the developer not fail.
Right.
Really.
Yeah, well, so one other big thing that I think we focus on, and part of it is something that we hear a lot, at Reinvent, is you just look at the number of services that AWS has and the amount of rich building blocks that are available, and it's something that's intimidating, for a lot of developers, right? A lot of the folks here at the conference, they're excited about it. They're keeping
What's
up with all the
intimidating?
news. Oh, just the amount of surface area there is, the amount of different options they have, the amount of for each one of these things, the amount of configurability there is, and if they have a problem, turning that, going from I have this problem I want to solve to here's the architecture I want to use to here's the several thousand lines of cloud formation that I need to use to sort of describe that and tell AWS to create all that infrastructure for me, is a complicated process today. And so one of the things that we have been doing some work on as well is really building some libraries that sit kind of as a layer on top of what AWS provides. AWS provides those amazing building blocks, but we look to building libraries which sort of take a bunch of those building blocks, provide a simpler surface area over them that makes them easier to access, and then that's something that developers can use. It becomes
So
almost,
these are patterns that you're able to help
they're
developers build upon.
Right, they're sort of best practices patterns. One of the ways we kind of talk about it sometimes these days is sort of architecture as code almost instead of infrastructure as code. So instead of you just going and doing each of the individual pieces of infrastructure, working at a level that's a bit more like what you would draw on the whiteboard when you draw your architecture diagram, right? You'd say, I want an SQSQ here, I want an ECS task here, I want an S3 bucket here. You draw some lines, and can we make it so that the code you write is more like that than like what you really have to do today, which every one of those boxes is, a couple hundred lines of cloud formation that builds up 5 or 6 other auxiliary resources and all this sort of thing. There's a lot of complexity there for developers. And again, that sort of harkens back to the way we've thought about things from the application development side. We grew up, going from sort of the assembly code to C to Java to these high-level frameworks on top of Java, and developers have sort of moved up the abstraction level they work at consistently over that time. And it's not that the building blocks weren't powerful. The building blocks in Windows and Linux aren't powerful building blocks. It's that we need these higher level abstractions to empower developers to take advantage of them. And so I think we're kind of trying to play that same kind of playbook for the cloud platforms and really build some of the frameworks over top of the raw resources that help folks to productively use these platforms.
So they can do things such as providing that capability to more efficiently manage those inner loops, for example?
Yeah, I think it's really is the same kind of applications they can build, that they can just go from idea to implementation faster. They can iterate on those ideas faster. They can sort of progressively learn the complexity behind the scenes instead of having to absorb 100% of the complexity to even get started. And so a lot of those things that just make it feel easier to use use these cloud platforms.
Sure. So at least my question then about how teams are working together and what are you hearing from people about how their teams are changing now with faster development cycles, with more tool capabilities, with increasing concerns about security? What are some of the trends that you think about will play out more in the months and year ahead?
Yeah, no, I think there's been this continued trend, and I think it's going to accelerate over the next year or two, of moving a lot of this infrastructure stuff, cloud infrastructure, towards the development teams. And you're seeing that in some verticals. You're seeing that very heavily already. Like you see things like serverless. That infrastructure tends to actually be something that's owned by development teams. It's something that iterates with their application code, not with some core platform team. And so you're seeing, folks doing that kind of work, inside development teams. But those teams are often finding, oh, well, I actually also need, a DynamoDB table. I also need all these other pieces of infrastructure. And so I want sort of more of those full capabilities, but I don't want to drop down into these really low-level tools. And so I think we are seeing that shift to where development teams are becoming more involved in how their code gets into the cloud and what the resources are that their code is built out of in the cloud. And then I think the other part is just the rapidly increasing complexity of what folks are doing in the cloud. And so even those, central, infrastructure teams inside most organizations, they are going from, hey, we had, a couple hundred lines of cloud formation or something, to, hey, I've got 100,000 lines of cloud formation, right? These enormous increases in the complexity of what they're managing. And they're realizing that, this is this really critical asset for them, and they don't have the same, tools available to manage that. And so they're looking for they're looking to be able to test this stuff. And they're saying, hey, if we can't test this, we can't have confidence that we can change it. Right. And so even the sort of existing teams are sort of, when we're talking to them, they're asking, hey, do you have solutions for testing? Do you have solutions for compliance? Do you have solutions for empowering our development teams who are going to build on top of the platforms we're building to be able to move faster and take more ownership of this stuff? And that's really where we're focused.
Well, Luke, we covered some good ground here in our discussion today. And we talked about, these concepts about modern infrastructure as code and how, in your experiences from working at Microsoft and then Amazon, the differences in terms of building out developer tools and building out infrastructure, but now how we're starting to see that intersection of those two and how DevOps practices will increasingly be affected by that deployment, where it's almost like develop and manage increasingly instead of develop, deploy, and manage.
Right. Yep.
And that will be a trend that you're thinking will play out in 2020. So thank you for your time, and good luck at Reinvent, and thanks for joining us here at IFX.
Yeah, thanks so much for having me.
You bet. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time. Cloud-based Jenkins X has a new UI made for the demands of continuous development. To learn more about Cloudbees, Jenkins X, and the Cloudbees leadership in CI/CD at cloudbees.com.